Okay, so I'm going to look at solving using the quadratic formula, where ax squared plus bx plus c equals 0. So that's a quadratic that you'd be familiar with, just that we've replaced the numbers with letters. So I want to introduce this particular formula, and you'll eventually see where it comes from. But for the moment, I just want you to know just one thing about it, which is just a precursor to something a little bit later. This thing under the square root is what's called the discriminant. And this will become very important when it comes to solving and how you can solve quadratics, but we'll talk about that a little bit later. What I'm going to do is I'm going to show you how you can solve this quadratic expression. In fact, it should actually be an equation. We'll make that equal to 0. By 3 methods, they should all get you the same answer. So I'm going to start with factorizing. The plus and minus means that there's 2 answers, one that has a positive there and one that has a minus. So for example, the way that, I'm very glad that you asked that because you may not have seen that before. So what that means is that there's 2 values for x, one that is a plus square root b squared minus 4ac over 2a. There's one where it's minus square root b squared minus, I should keep my b's consistent. You'll find that it's not quite as daunting as that, because I'll show you how you substitute that in. You don't have to keep repeating things twice. Okay, so by factorizing, I just need to find 2 numbers that multiply together to get negative 12, add together to get 1. Can anyone think of what they might be? Yeah? Well,
3 and 4.
Okay, so positive 4, negative 3. So, let's see, x plus 4, x minus 3 equals 0. So either x is equal to negative 4 or x is equal to 3. Great. Now, if I want to do it by the method of completing the square. So completing the square involves halving the middle term. That was the whole thing about when we broke up the middle section, the rectangle, into 2 smaller squares. So what we end up doing. Now, what's the number in front of the middle term? What would be the number there?
1.
Yeah, it'll be 1. So I'm going to add 1 over 2 squared minus 1 over 2 squared. No. 12 equals 0. So you remember, this was that plus and minus thing that I was talking about when we were doing completing the square. So this now becomes x plus 1/2 all squared minus 1/4 minus 12 equals 0. Okay, because 1 squared, 1/2 squared would be 1/4. Yep. So negative 1/4 minus 12 would end up becoming negative 49 over 4 equals 0. So now we need to solve. We can see here this is in the form of something squared minus something else squared equals 0. So we can get this into 2 brackets. And so this becomes x plus 1/2, x plus 1/2 minus, what would be the square root of 49?
7.
And the square root of 4?
2.
And so plus 7 over 2. And so this will now become, so each one of these brackets could be equal to 0. So the 49 came from the fact is, what's 1/4 take away 12? 12 expressed as a fraction would be 48 over 4. So negative 1/4 minus 48 over 4 would make that negative 49 over 4. So that's what I just turned the number into a fraction.
This is like, factorizing is too easy. Let's just make 10 lines into it.
Okay, so x plus 1/2 take away 7 over 2. So 1/2 take away 7 over 2, what would I have left? What's 1/2 minus 7 halves?
Minus negative 6 over 2.
And a half plus 7 over 2?
8 over 2. So that's
What's 6 over 2?
3.
And what's 8 over 2?
4. So x equals positive 3x.
Yep, so we've shown that by completing the square, I get the same answer as we do in part A. So, but why? So you're probably wondering, that seems much harder than necessary. Completing the square should only be used when you can't factorize into brackets. When you have to solve a quadratic equation that doesn't fit nicely into 2 brackets, then you complete the square. The quadratic formula, which is, so it requires an equation to be in the form of ax squared plus bx plus c. Our equation is x squared plus x minus 12. What would the letter a be equal to? 1. Why?
Because that's the number in front of x squared.
Yep, the number in front of the x squared would be 1. What would b be equal to? 1, because the number in front of x is 1. And what would c be equal to? Negative 12. So, that it is. So, if I just substitute these all in, so they'll become negative 1 plus or minus 1 squared minus 4 times 1 times negative 12 over 2 times 1. Negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 12. What is 4 times 1 times negative 12?
Negative 48.
Well, there's 2 minuses there, so that'll become positive 48 over 2. What's 1 plus 48?
49 over 2. Oh, we've seen that before.
So you can see here, this now becomes negative 1. What's the square root of 49?
7.
Okay. So our answers are that x is equal to negative 1 plus 7 over 2, or negative 1 minus. Get rid of that square root.
At the top, is it 4 times 1x or?
Yeah, 4 times 1 times negative 12. Is that, when you say at the top, is that what you mean?
Yeah.
Would you not simplify that fraction?
That's what I'm about to do now. So negative 1 plus 7 over 2 is going to become,
6.
yeah, so, well,
So many arrows.
6 over 2. Negative 1 minus 7 over 2 will become negative 8 over 2. There. And so x is equal to 3 and negative 4. So we managed to prove we can factorize using the quadratic formula.